Hi everyone, welcome to Explore Secondary Math Topics with Teacher Ben. Now for this video, we'll be talking about number patterns. Now I have one student who actually asked me this question. So this question is actually from 10 year series 2015 paper 2 question 8. This is a E-math question. So let's start looking at the question. So the first four terms in the sequence are 55, 51, 47 and 43. So our job is to find an expression in terms of n for the nth term Tn of this sequence. Now for part 2, we need to evaluate T25, which is when n is equal to 25. Okay, so let's look at part A first. So we have 55 and we will jump to 51. So the simplest way is to look at addition or subtraction. So this means that I have to do a minus 4. Now from 51 to 47, now in this case we notice that is another minus 4. So and from 47 to 43 we do another minus 4. Now so by looking at this, we know that it's actually an arithmetic sequence. So this is pretty straightforward. So for part A, now in order to come up with an arithmetic sequence, what you can do is you can first write down the first term. In this case the first term is 55, so let me write down 55 first. Okay, now this is reducing. We try to reduce by 4, reduce by 4, reduce by 4. So I will introduce a minus. Now this is in the multiples of 4, so I put a 4n. Okay, now the thing is our first term should be 55. Now when n is equal to 1, what will happen is we will take 55 minus 4, right? Because 4 times 1 will give me 4. So in order to keep 55, I need to do an addition of 4. So that this minus 4 and this 4 will net off. Now after doing this, what you need to do is you need to simplify this. Okay, so 55 and positive 4 you can add up to give you 59. So it will be 55 minus away 4n. So this will be the term, the n term. Okay, so this is for part 1. So now let's look at part 2. Once you have the nth term, what you can do is you can do a check. So let me use another color, do a check. So let's say that when n is equal to 2, so what will happen to my t? So my n will become t2. So I'm going to have 59 minus away 4 times 2. So you notice that this will give me 51. Now if I try n equal to 3, so that will give me t3. So it will be 59 minus away 4 times 3, that will give me minus 12. So I'm going to get 47. Okay, so by doing this testing, that will give you comfort about your A part 1. Now next, what you need to do is just let your n be equal to 25. So t will be equal to 25. So we're going to get 59 minus 4 times 25. Now don't worry, your number will be negative. So you're going to get negative 41. Okay, so this will be the answer for A part 1 and part 2. Now the more challenging part will be the part B. So let's go and understand it first. So the diagram shows part of a number grid. So we have 1 all the way to 8, then second row will be 9 all the way to 16, 17 to 24, 25 to 32, then we have a cut off, so we have 33, 34, then there's a cut off 35, 36. Now they also highlight four boxes. So they actually mention something below. A square outlining 4 numbers as shown can be placed anywhere on the grid. So they can actually shift this to anywhere of the grid. Okay, this black color box. Okay, can shift it anywhere. Now if n represent the number in the top left corner of the square, so this square they are talking about the black gray square. Okay, so write down an expression in terms of n. The number in the bottom, they want to find out what's the number in the bottom right corner of the square. So let's look at what it means. So if we just export the black square out, so we're gonna have 4 numbers here. Now this n represents the top left corner of the square, so that will be here. Okay, now if you look at, if it's 11, the square at the right side will be actually additional of 1. So if I shift this, let's say I shift this to here, so this will be n. You'll notice that it's always additional of 1, right? So this means that the top right corner will be n plus 1. Okay, if you look at the bottom, it will be additional of 8. So if I shift it to any part, let's say it's here, so 14 to get 22, additional of 8. So I know that this will be n plus 8. Okay, so if you move to the right side, it will be additional of 1, so this will be n plus 9. Okay, so by doing this, I know that my b part 1 will be n plus 9. Okay, now we have to show the difference between the product. So difference between the products of the numbers in the opposite corners of the square is always 8. Okay, so this means that if you take n, we have to multiply the opposite corners. Opposite corner. Then if you take n plus 1, it will be another opposite corner, which is n plus 8. Okay, we need to multiply this and subtract. Now the thing that I want to know is, they say that it's always 8, right? It's a positive 8. So we need to take the bigger product minus away the smaller product. So I will just look at the number and make a guess, or I will just think whether it's logical to put which first to be the bigger products, then we can minus the smaller product. Now if you take 11 times 20, then if you look at 19 times 12, you'll notice that 19 times 12 will give you a bigger number. So let's do a test with our calculator. Okay, so let's try. If I take 11 times 20, so that will give me 220. If I take 19 times 12, so 19 times 12, that will give me 228. So you notice that n plus 1 times n plus 8 will give me a bigger product. So n plus 1 up to n plus 1, if you multiply by n plus 8, then if you minus away n times n plus 9, so we want to prove that this will give me 8. So that will show that this sequence will always give me 8. So let's solve this and simplify it. So we can actually expand this. So it will be n times n, so that will give me an n square times n. So usually I'll do this and times n plus another 8n. Then I'll take 1 plus 1 times n, that will give me n. Then 1 times 8, that will give me 8. Then we have to minus. So this one you multiply it in, so that will give me an n square. Then minus 9n. Okay, so let's simplify. So we're going to get n square plus 9n plus 8 minus n square minus 9n. Now from here you can notice that this n square and this n square will cancel out. This 9n and this negative 9n will cancel out. So in the end I left with 8. So I already showed that for the difference of the products of numbers in the opposite corners, it will always give you 8. Okay, now let's try the last one, which is part 3. Now they want us to show that the sum of the 4 numbers in the square cannot be 260. Okay, so let's try. We have to use the general term. So we take n plus 1 plus n plus 8 plus n plus 9. Now let's show that this is actually equal to 260. So we're just going to see whether it makes sense or not. So this n plus n plus n plus, that's 4n, so it becomes 4n. Plus here we have 1, 9 and 8, so our n will be 18, so it will be equal to 260. So bring this positive 8 to the right side, so it will be n equal to 260 minus away 18. So I'm going to get 4n equal to 242. So I will notice that my n will be equal to 60.5. So basically I'm taking 242 divided by 4. Now, if you notice that your n represent a number in the top left corner of the square, right? So if that is the case, you notice that your n is always an integer. So when you solve the sum of the 4 numbers which equal to 260, it will give you n equal to 60.5. Now since, let me just segregate this. Now since n is not an integer. So we can actually say that hence sum of 4 numbers in the square cannot be 260. So this is what we can conclude, cannot be 260. Okay, now this is the way to solve this sequence question. So if you have any doubts or question, you can actually check with us. You can leave your comments in the box below, then we will get back to you. Okay, so that's all for this question. So don't forget to follow us and also subscribe to our YouTube channel Conceptual Thinkers, and also follow us on our Facebook Conceptual Thinkers Mathematics and English Hub. Okay, so please feel free to share any of the question in the comments box below, then we will try our best to get back to you. Okay, so that's all for this video. I will see you in the next video. Bye.